talk about the the Kun net framework of a whole set of paradigm shifts that AI has gone through, right?
Right, right.
What are the paradigm shifts that AI has gone through, and what impact has each of these shifts happened for the business and the society at large? So, what are these shifts that you have seen, and can you talk to us about it?
Yeah, that's a great question. And, there's this article I wrote called The Paradigm Shifts in Artificial Intelligence that I posted on Archive last year, which I initially wrote as sort of an initial opening article for a PhD seminar that I was co-teaching, just to give students kind of a grounding about the history of AI and what got us here and why does it matter. And so I start the sort of story of the or rather the history of AI, at the end of sort of what I call the game playing era. In the 60s, there was a lot of experimentation with sort of game playing algorithms for searching graphs, which sort of came out of the areas of sort of optimization and search. But in the 70s, I'd say there was a whole new, era of what I call expert systems that got going, where people felt that for specific domains like medicine, which is the poster child for AI, and engineering and, problems with a certain amount of structure in it, you should be able to talk to human experts and extract their expertise in a way that was representable in a machine that could then be used for reasoning about that domain. So medical diagnosis, being a prime example where the system that I referred to, Internist, had been built over 10 years of interaction between computer scientists and specialists, diagnosticians in medicine. And the knowledge had been extracted case by case, carefully assembled, represented, in the forms of hierarchies, rules, causal relationships, all of that kind of stuff. The knowledge was extracted and declared, and then there was a way to sort of use it, in the context of a new case. And that's what I was observing. My first interaction with AI was this expert systems paradigm and expert physician discussing a case with Internist. And I'll come full circle to this, by the way. So that was the expert systems era, but it was, very hard to extract knowledge reliably from experts and to represent things like uncertainty, right? Yeah. Because at that time, people were thinking about knowledge in terms of rules, but then how do you attach uncertainty and context and all that? So it becomes really difficult to do that in a top-down way. And the machine learning era sort of started emerging in the 80s and 90s, where people were saying, hey, why, sort of like trying to specify these rules, why can't we learn them from the data? Let's just look at lots of cases about medical diagnosis, and from those abstract out, the knowledge which can then be applied, right? So that was sort of the next era of machine learning, where you could take data, you could, do what was called feature engineering, curate it properly, and then use a machine learning algorithm to extract patterns from data, to say that if I see someone has pallor, then maybe they have excess bilirubin. And so maybe there's something causing that elevated level of bilirubin in the blood, right? So that was the context. So now you could actually derive those rules instead of having an expert specify them. But it was still really cumbersome to do feature engineering, right? So if you had to, let's say, use an X-ray image or an MRI as part of diagnosis, the physician had to translate that into a vocabulary and say that to the machine, right? So that wasn't great. And so what the sort of new sort of deep learning paradigm did was that it solved perception, right? That now computers could actually see the world and listen to it and read about it, in the way that humans do. And so they could ingest the input directly from the environment. So that was a big deal, was solving perception. Right? Yeah. So intelligence sort of went more upstream. Okay. And then the latest paradigm shift, which I call, the shift to general intelligence, is this emergence of these pre-trained models like large language models that are just pre-trained with, lots of knowledge that is available on the internet. But they're not pre-trained with any specific purpose necessarily, other than predict the next word. But it turns out that they learn a lot about the world just by doing, prediction of the next word. And they're usable for all kinds of things, like
Mm.
general question answering systems, writing code, and all that kind of stuff, right? Now, I'll end by saying this. I took some of the dialogues that I had, from internist days, and I
Yeah.
tried working with ChatGPT. I fed ChatGPT the exact same symptoms about a
Mm.
case, and I said, what's going on in this case? Right?
Mm.
And ChatGPT actually was amazing, right? Because it's very conversational. It said, "Oh, yeah, I see what's going on here. Maybe there's blah blah blah," and then it just stops, and
Mm.
that's it, And then I'm like, "But tell me more," and it's like, "Well, what do you mean?" And so then I have to sort of feed it another symptom, like which internist had sort of asked for, right? Like,
Mm.
oh, was there a pain in the lower left quadrant, right? So then I'm telling ChatGPT, by the way, there was no pain in the,
Mm.
after the patient had a big meal, and
Mm.
so ChatGPT says, oh, okay, that's good evidence. In that case, and then it chugs along a little bit more and gives me all kinds of stuff. But
Okay.
it hasn't gotten to the point where it gives me the kind of dialogue that I could
Mm.
have with internists,
Mm.
50 years ago.
Mm.
So we've come a long way, from the days of specifying knowledge to the machine just learning everything on its own, which is where we are now. But
Mm.
we still have a very long ways to go in terms of like, reaching, human levels of intelligence. But I think we will get there, and I think the machine will even surpass us, in the future.
Brilliant. I think your way of summarizing the four eras was just quite amazing and very, very, I would say very vivid is what I would call it.